guys, welcome back to another dynamics physics problem, this one on the gravitational and normal forces. A 25 kilogram box rests on a table. A. What is the weight of the box and the normal force acting on it? And B. A 15 kilogram box is placed on top of the 25 kilogram box as shown below. Determine the normal force that the table exerts on the 25 kilogram box and the normal force that the 25 kilogram box exerts on the 15 kilogram box. Okay, so starting off with part A. In part A, all you have is this box right here, the 25 kilogram. Okay, so for this, what is the weight of the box? In the previous video, number 55, you would have seen that weight is a vector quantity and weight is represented by the force of gravity. Okay, so the weight for box 1 is equal to the force of gravity on box 1, which is equal to the mass of 1 times g. Okay, the mass of box 1 is 25.0 kilograms. Acceleration due to gravity, 9.8. Now, usually I write meters per second squared, but acceleration due to gravity can also be expressed in terms of the following units, newtons per kilogram. It's a simple mathematical step to show how newtons per kilogram is equivalent to meters per second squared. Okay, if you have questions on how to do that, please leave a comment in the video comments under the video. Okay, so the product of these two comes out to be 245 newtons. So that is the weight of the box. Right. Now, for the next part, what is the normal force acting on it? Okay, so here's what we want to look at here. Okay, so you've got box 1 sitting on a table, and you've got some forces acting on it here. You've got the gravitational force, you've got Fg1 acting on it. Now, you have another force acting on it, right? The table's pushing back up on the box. According to Newton's third law of action-reaction forces, when object A applies a force onto object B applies an equal in magnitude, opposite in direction force back onto object A. Okay, so in this scenario, the box's weight is actually pushing on the table, right? I mean, if the weight is too much and the table cannot sustain it, the table will break. Okay, but in this case, the table is able to push back with an equal but opposite force, which we call the normal force, the perpendicular force of a surface counteracting the weight of this box. Okay, so to determine the normal force, we want to look at this idea here. Okay, so since the acceleration is 0, this box is not accelerating up or down, and we're dealing with the y direction here. Therefore, the net force is also equal to 0. These are very important things to establish in the beginning of a problem, because if they do hold true, it simplifies your problem a great deal. Okay, so we've got F net is equal to, now we need directions here, so why don't we let positive be the upward direction? Okay, so therefore normal force is in the positive direction, gravity is in the negative, so F net is equal to Fn1 minus Fg1, and we know that the sum of those two has to be equal to 0 since net force is 0. If we bring Fg1 over to the right side, we get Fn1 equals Fg1. Therefore, Fn1 equals 245 newtons. So there's the normal force on box 1, 25.0 kilograms. And those are the answers for part A. Hopefully pretty straightforward. Okay, now for part B, a 15 kilogram box is not placed on top of the 25 kilogram box. Determine the normal force the table exerts on the 25 kilogram box and the normal force that the 25 kilogram box exerts on the 15 kilogram box. Okay, so you have to really think this out logically. Okay, so originally we just had the 25 kilogram box, its weight was pushing down, table's pushing back up on this weight. Now you've got another weight put on top of it. So now the table is being pushed down with a total combined mass of 40 kilograms. So it's going to push back up with a force equal to the 40 kilograms times acceleration due to gravity. Why? Because it doesn't know that there's two separate objects here. All it knows is that there's a massive or a more massive weight pushing down on it. Okay, so however, although it's a more massive weight, something holds true as did in the previous problem. The two boxes are not accelerating up or down, so we can say that the net force is equal to 0. And it's the same idea. You've got a normal force going up, you've got a gravitational force going down. Okay, so we've got a normal force, we'll say total normal force plus total gravitational force. keep those vector symbols, equals 0. Now, if I want to drop the symbols, I have to assign directions. So gravity is going down, normal force is going up. So Fnt minus Fgt equals 0. Therefore, the normal force is equal to the gravitational force by magnitude. Okay. Let's keep going down here. So the total normal force is equal to the combined mass of 1 and 2 times the acceleration due to gravity. Their combined mass is 40.0 kilograms. The acceleration due to gravity, 9.8 newtons per kilogram. When you multiply those two out together, you are going to get the combined normal force to be 392 newtons. Okay, so this is for the combined weight pushing down of 40 kilograms. But it's the 25 kilogram box that experiences this normal force. Okay, so that's for the first part of part B. And now we have to find the normal force that the 25 kilogram box exerts on the 15 kilogram box. Let's take a look at that image again. Okay, the normal force that this exerts on the 15. So something you got to understand here is that when the first box was on the table has a mass as well, right? Although it's not stated, it's whatever that mass is, applying a force back on the 25 kilogram box. So it really doesn't matter that the 15 kilogram box is on the 25 kilogram box. Assume that this is just another table, and imagine the mass was not given to you. Your 15 kilogram box is sitting on some kind of table, and its weight is pushing down on this table, and the table is pushing back up with a normal force equal in magnitude to its weight. So that's what the 25 kilogram box is doing. It's pushing back up equal in magnitude to that box's weight. Okay, so all we need to do for the next part is say, you know what, the normal force that box 2 is pushing up at is going to be equal to the weight of box 2. And that's equal to the mass of box 2 times acceleration due to gravity. So 15.0 kilograms times 9.8 newtons per kilogram. When you multiply those two out, you are going to get 147 newtons. So that is the normal force acting on box 2 by box 1. So that's it for this video, guys. If you enjoyed it, be sure to click that like button and subscribe to Physics in the Flesh so you never miss a video from me. I post every weekday at 12 noon, so be sure to be on my channel at that time to catch my latest video. Okay, guys, I will talk to you later. Enjoy the rest of your day.